How'd this one go? So on our quadratic flowchart, our first question is there a bx term? What do you say on that? Yeah. So we have two options. You can try factoring. And for that we need to look, well, we need first to set equal to 0 and then look for a GCF. We can also try, if factoring doesn't work, we can try the quadratic formula. And for that, also set equal to 0. And wait, do you mind shutting the door? We don't need to worry about a GCF. It could help it be easier if you pulled out a GCF, but we don't have to do it. Anyway, so let's do 11r squared plus 7r minus 3 equals 0. And so then we try the star, and we're looking at factors of negative 33 that add up to 7. If we put those in there, are there any factors that do that? No, so we need to use what? Do you guys have that written down somewhere?
I have it memorized.
Or memorized? Sometimes you'll see it with just a single fraction bar and just 2a under both things. So like that. But it doesn't matter which way you write it. This says opposite of b. So if b is negative, like if this was negative 7, you would want to make sure to get both the two negatives. But in this case, it's just 7. Why is there a plus or minus?
Because you solve for you add 2 and then you subtract.
Yeah. So this first term doesn't really simplify too much. Then we get 49 plus 44 times 3, because we have 2 negatives, so it's going to be plus. So what is that? 44 times 3. 132, I think. What's on right? Oh, 40. Sorry, I forgot to add the 49. Well, let's do that in 2
Negative
steps.
1 3. Negative 2.
Yeah, it's positive.
Oh yeah, now.
At what point could you dive into your calculator on this?
Maybe to figure out the
Yeah. Honestly, if you're careful, and if you have a graphing calculator, if you're careful, you could really punch this whole thing in here into your calculator, picking either plus or minus, not both, of course, and that would give you a decimal. Or any other place after that. Again, I say be careful because there's so many little nuances with exponents and signs. So if you enter it just like we wrote it, that would be fine. Your calculator can handle that. Anyway, square root of 181 is not a perfect square, so that itself will be a decimal. You guys remember simplifying radicals? Like square root of 150, how do we simplify that?
it'd be like 25.
Like 10
10 is not a perfect square, so we don't use
not
it.
10.
So 25 and 6, excuse me, 6 would work. What else? Or is there anything else?
Well, you can simplify it even
Well, true, but I'm saying if we hadn't thought of 25 and 6, what else could you try?
Do
10 and 15 are not perfect squares, so they don't matter, right? What do we divide by? What do we try to split this up by?
a perfect square.
Yeah, so like does 4 go in? No. 9, no. 16, no. 25, we already did. 36, no. 49, no. Etc. 64, 81. 81 is over half, so 25 is the only one. Okay? Can we do that with 181? Does 4 go into 181? No. Do you guys know how to check if 4 goes into something?
No.
Well, write this down. I'm not going to write it, but if the last 2 digits are divisible by 4, then 4 goes in. So like 132, 32 is divisible by 4, so 132 would be divisible by 4. But 81, not that way. How about 9?
No.
Well, to check if it's divisible by 3, we add the digits. So 1 plus 8 plus 1 is 10. And 10 is not divisible by 3. So neither is 181. And that probably means it's not divisible by 9, because that would mean it has a factor of 3, right? So we can eliminate 9. Okay, how about 16? Well, 4 didn't work, so will 16? No. 25, of course, no. 36? 49? Okay, and then 64, 81, and then 100 is over half. So this is not going to work, right? We're not going to be able to simplify it. So you could leave it as this answer. You could combine the numerators like that. Since there's nothing that we can simplify, that would be an acceptable way to give your answer. If you did do a decimal, what would you have to do? Everybody do that. Give me the 2 decimals. Use your calculator. Give me the 2 decimal answers for that.
For the addition, it's 0.93.
Yeah, we should be getting close to 1 and like close to negative 0.4 or so.
Yeah, for subtraction, that's negative 0.2.
Oh yeah, 0.3, I should have said. Okay, so if you're confused, this is what you do. 7 plus square root of 181. And then divide by 22. So there's one of our... I did something wrong.
You forgot the negative minus.
Thanks. Plus 181 over 22. There we go.
And you would want to add negative 7 and the square root of 81.
There we go. And then I would just, if you have one of these calculators, just go grab this whole thing and go
That was okay.
change that to minus.
That's still incorrect. Because you're using the subtract.
Negative 7 plus, this, I need parentheses, that's why. Ugh. There we go. Okay. Do you see why I said careful? Unlike what I did. Alright. So keep this kind of tucked away in case you need it. The quadratic formula, it's a good tool. Let's check your homework problems, and there they are. So just page 4. Okay, 24, you should have got 6 and 4. 25, 9 and 12.
Yeah.
26, 4/3 and 2. 4/3 and 2. Okay, 27. X was 12 and a half. Y is 3. 28, X is 5, Y is 4. And 29, X is 2, NM is 7, ML is 14. Any questions, or do we need to do any of those? Yeah, Gabriel?
28.
28, okay. Okay, so again, it takes a little bit of practice to start seeing 2 triangles in these for some people, which is fine. So once you do see them, I would draw them separately and label everything that you know. So on the blue one, left side is 2, right side is 3, and bottom is Y. On the other one, we have 2 plus x minus 1, and 3 plus x plus 1. And can you tell me what that is, since I cut it off?
12.
12, okay. Then we just set up proportions that keep x's and y's separate so that we can solve. So, like for x, maybe do 2, 2, 2. Actually, let's just go ahead and combine these. So 2 minus 1 is just 1. And 3, same thing over there, we'll do x plus 4. So 3 over x plus 4. And in terms of ratio, I'm sticking with blue to red. That was kind of the strategy. That looks like division. I better not do it that way. Again, just make sure you're staying consistent, right? So I did left side of blue to left side of red, right side of blue to right side of red. There's usually 2 things that you need to make sure are consistent. Which figure comes first and which side or size comes first. So I could say, like I did, left to left, blue to red, right to right, blue to red. Both things have to be consistent. Do you feel like you're doing pretty well on the setup? Like keeping things consistent? Okay. Alright, anyway, now we're ready to do our cross products, and we'll get 2x plus 8, or maybe don't skip the step. So 2, reminding that you need to have the parentheses, and then 3 and 1 plus x. And we'll get x is 5. But so far so good. And then for y, how about you tell us what you would do for y?
Then, I mean, now that you know x, you can use x and then simplify it. So
Yeah.
it'd be like 2 plus, and x is what?
X is 5, so 2 plus 4.
Yeah, 2 plus
So I'm doing 2 to 6, right? And then y to 12. So this one we don't need to do the cross products because we can see the scale factor is 2. So y can just be 4. Good. Any others you'd like to do? Okay. So this is the same idea as the other figure, just sort of turned on its side, I guess. But I still see two triangles, a small one and then a bigger one. And so small upper right, I guess we could name it, 6x plus 2. And then bottom, KL, is 16. How did we get 16? Yeah, so since the whole thing is 24 and this little segment is 8, that leaves that as 16. Okay, big figure 24 and x plus 5 plus 6x plus 2 for the right side, upper right side. Okay, then we just set up consistent proportion, so 6x plus 2 top right to top right over x plus 5 plus 6x plus 2 equals 16 over 24. Combine those. So 24 times the numerator of the left one. And then this is 7x plus 7. And then solve from there. You good from there? Or we can do it if you want. Yes, do it. Okay. So 24 times 6.
144.
And what is it?
144x. 40.
Okay. Let's put our x's on the left side. This one? And 32. There we go. Thanks. Did you see where we went? Alright, any others? How are these going for you? Like, there were 6 total problems. There were several answers for on most of them. Actually, all of them. But let's just call getting all of one correct. So, hold up how many you got out of 6.
If you gave me enough time, I would have had this many.
Okay, that looks good. Why don't you grab your notes about the area and perimeter ratios? Yesterday we talked about how scale factor or just scaling ratios work with either sides, which includes perimeter or area. And we had a few different ways to write it, but how did we use a ratio or scale factor with side lengths or perimeter? Like if I did this, original perimeter times what equals new perimeter, what would you substitute in there? Yeah, or just times the scale factor, right? Just if it was 3 times bigger, so is the perimeter. Over here, if we had the original area and wanted the new one, what would we do with that?
Scale factor squared.
Good. Okay, so scale factor squared. And this took different forms depending what we were working with. Meaning, maybe it wasn't just a single number like times 2. Maybe we set it up as a ratio, like 1/2 with our other perimeters on the other side. Okay, same thing here. So you'll need to be able to work with this in multiple forms, but the concept is always the same. If it's 2-dimensional, we got to square something. If it's 1-dimensional, probably we'll square root. You will square root eventually. Okay, so we had this example right at the end of class where we were given a ratio of lengths. It says sides, that was length, which is 1-dimensional. And it said find the area of a large the larger triangle room if we had the small area given. So at first we wrote 2 to 7, which was one-dimensional, and we want to make that equal to 25 to some larger area. But we fixed this one-dimensional mismatch, the 1D, 2D mismatch, by squaring the one-dimensional. Remember doing that? Okay? Once we squared, when you square a fraction, you just square both, so it became 4 over 49. Once we were at that point, it was just solving a ratio, or excuse me, a proportion as normal. Okay? Were there any questions? That was kind of right at the end of class. Were there any questions on it? Okay. So I want to do one more example and then we'll go right about it in your notes. So the area ratio is how many dimensions? This is 2D now, right? We're given a 2-dimensional ratio, scale factor, etc. So 49 to 81, how nice that they gave us perfect squares. If the longer side of the smaller home is 20 feet, what is the length of the corresponding side of the larger home? So we're bringing in quite a few different concepts here, starting with being consistent. So you can do big to small or small to big. It actually doesn't matter at all. Do you guys find yourself doing one or the other consistently?
Yeah.
Raise your hand if you do it this first way, just because I'm curious. All right, raise your hand if you did it that way. Okay. So small to big, again, it's given as 49 over 81, and that is 2-dimensional. I'm going to write that below, I think. And then we have to, on this side, match. So the longer side, that's an important word. This is a length, not an area of the smaller home.
So that would be the bigger.
So 20 feet, the longer side of the small home. Okay. Cool, thank you. Is 20. And it says, what's the length of the corresponding side of the larger home? So you can just put an L maybe, or X if you want to. But that is how many dimensions? Yeah. Okay. If things are not super clear still, maybe label this as feet and this as feet squared. Now, obviously 49 square feet, that's a ratio. That it would be definitely a reduced ratio. It's not like our small home is 49 square feet. That's like barely bigger than my desk, okay? Like double my desk or so, maybe triple. So label those so that you can see square feet versus linear feet, and maybe that will continue to help you see the dimensions of it. All right, so this time we are solving for a one-dimensional quantity, so we need to make our two ratios match dimensions. How do we fix the 2D to a 1D? Yeah. So we're going to square root. Now, when you square root a fraction, what do you end up doing? Yeah, you can just square root both numerator and denominator. Okay, and now you can see why it was given as 49 to 81. Not that it always will be.
How do you choose whether to square root or square the 1D side?
Okay. Can I answer that in just a second? And let's go ahead and finish this. Okay, how long is L? Someone do that for me, please. Okay, sorry, what was it? Guys, one nice thing about these story problems is ones that have a context with them is I guess even with ones that don't, but it makes more sense in these. It's really easy to check if your answer at least makes sense, right? We just found the length of the larger home better be bigger than the length of the smaller one, right? So if you did something wrong, that kind of reinforces It's a good check. Like if we had solved and gotten 15 feet, well that's weird. That's not the larger home run, right? All right, so Cooper asked, how do you know if we're square rooting like this problem, or if we're squaring like this problem? Any thoughts?
Never mind.
Just like what we were trying to find in the end, like in the first problem we were trying to find the area, but we were given a perimeter, and the second problem we were trying to find the perimeter, but we were given
Good. So yes, it's all determined by what you're solving for. If you're solving for one dimension, then you're going to square root if you're given a 2 dimension. What if we were given a perimeter ratio? Then what?
You would split it to the other.
No. Then we would just solve with it, right? You got to make sure you don't just memorize rules and actually do the analysis. Is this 2D or 1D? Is this 2D or 1D? And you only have to square root or square if they don't match. If they already match, you just use it like normal, okay? In other words, if this had said, instead of area ratio, if it had said the perimeter ratio, 49 to 81, no square rooting, just solve. Okay? So you're gonna have to read these carefully. Any questions on that one?
What if they're both like 1D, but we're looking for the area? So then would we solve and then just square it?
So that was like this one. We're looking for an area but given a one-dimensional ratio. So we squared that to get it 2D. So that they match. And if you follow the units, it kind of makes sense. Here's why. If we had not square rooted, let's see, I'll write it over here. This would be feet squared, and then feet and feet. Okay, so we would get 49L, and what would the units be? Feet squared times feet is what? Cubic feet, yep. And then 20 times 81 would be 1800. Also feet cubed. Okay. And then we're going to divide. I probably shouldn't write it as feet cubed. It's probably going to confuse you. So let's just fix that. 1800. I'll leave this one as feet cubed just because it's a number. But 49 is feet squared. And L is feet. Okay? And so if I divide by 49, I don't know what that is. It doesn't actually matter. It will say L is feet. It's a little bit of a weird way to think through it, I think, probably for most people. Okay? So let's go back to saying make your dimensions match. It's really just coming down to that. Okay? If they already do, you're fine. If not, you got to square root. If we were doing volume, cube root, right? You got to make those match. What if it was an area ratio and you're solving for volume? So you have a 2D, now you have a 3D.
What if the square root and then cube?
Yeah, it's 3 halves, right? I guess it would be 3 halves, so squared to cubed. Yeah. Good. All right, let's go write some notes. Would you rather have all this in an example box or in a description, like these kind? Okay. That was decisive. The only thing with doing it this way is I do have a couple of just additional things to write. So maybe we'll put those over here first. Area is 2-dimensional. Perimeter is 1-dimensional. Let's stick volume on here too.
Do we have anything that's like 4-dimensional?
Who's we?
Like, is there just anything that's 4-dimensional?
Yeah, and lots more than that.
What do we call it? Because we have the area, perimeter, volume.
Oh, I see what you're saying.
Fourth
Yeah, not like a single name like that. But yes, we do calculations with more than 3 dimensions. All right, let's write a little problem. We've done houses. What should we do now?
toy cars.
Toy car.
Gardens.
Garden. Everybody good with the garden? I'm ashamed to admit, but is apartment 1P or 2?
It's one.
I need to write more.
I'm good with sticking to ELA for writing.
A small apartment has a garden with an area of, what would be a good one? Say 30 square feet. Balcony garden, maybe, and a raised bed or something, with a bottom on it. No, let's not say that. A farm has a garden with a length. What would be a good length for a garden farm?
30 feet.
30 feet?
There.
All right.
Let's go 5 with me.
By the way, we should have said a similar garden, right? That word. That word is what makes this whole thing work. If we don't have a similar garden, if we're comparing like a rectangle to a triangle or a circle or some weird shape, then it doesn't work. Has, how about this? A similar garden. We'll just take the A out right there. It is important to have that in there. If the length of the small garden is 3, that's really too easy. 4.5 feet. You guys know the little tick mark notation for feet?
That's just
Yeah.
one.
Like that?
Yeah.
And then inches.
Inches is 2. So if we related it to punctuation, feet would be an apostrophe, inches would be a quote mark. Have you seen that before?
Yeah.
Okay. Anyway, if the length of the small is 4.5 feet, what is the area of the farm garden? This will make us think of summer and nice weather instead of this garbage.
I hate
No offense.
Nah, it was cold this morning. I agree. I like the 60-degree weather.
Yeah, 60 is nice. I agree with that.
I like this one.
More close.
We had a really pretty sunset and sunrise. Last night sunset, this morning
Yeah,
sunset.
this morning was
Anyway, first step. Identify what you're solving for. And we're going to say 1D, 2D, or 3D. So what are we solving for?
the area that we were covering.
So what is that? Good. Okay. Step 2, set up a proportion. And just keep reminding you that it needs to be a consistent one, like correctly set up. And label the dimensions of each. Okay? Well, what is our proportion going to look like in this one? I would start by deciding if we're going small to big or big to small.
Small.
So which one do you want to do? We have 3 numbers. You might sometimes be given more than that. The big garden has 14 rows of corn or something, right? But do we need that? The small garden has 15 pea plants or something. Okay? What are we gonna write? What's our first ratio? Thank you, Gabe. Well, probably gonna be 4.5 to 30, right? And what dimensions does that have?
2.
That's 1. Because 4.5 is feet, 30 is feet. Those are linear measurements, right? Those are lengths. So that's 1D. That does not look like 1D. 1D. Okay, what's the other side? 30 to A. Okay? That's 2D. Those are areas. In fact, let's say underneath here, let's say this is length. These are areas. All right, step 3. Kind of the important critical step here. Make the dimensions match. Here's what Cooper asked. This is the step we're going to describe that on. Make both the same as what you're solving for. So what are we solving for? Is it a 2D or a 1D?
2D.
Okay. Solving for 2D. Okay, so we need to make these match 2D. Alright, I do want to continue on this. I wish I had maybe just put this somewhere else, but it's okay. I want to continue describing how on this one. Okay? 1D to 2D, what do we do?
Square.
Square. Square what?
The 1D.
Okay. 2D to 1D, what do we do?
Square root.
Yeah. Square root the 2D. What if we're... maybe we don't need to worry about the volume stuff. Let's keep it to this level for now.
Are we soon gonna...
That will be the last thing we do for this course. hopefully we'll get there. Alright, so what do we have to do on this one? On the one we're solving? Yeah. Okay, so that's going to make that 2D instead of 1. And the other side stays the same. And then last step is to solve like normal. So let's say solve the new version of the proportion. Okay, so we're going to take our cross products. We'll get 4.5 squared. Someone do that for us.
It's 20.25.
What was it?
4.5 squared is 20.25.
Thanks. And 30 squared is 900 times 30. Is that 27,000? Someone divide that for me. 27,000 divided by
4,333.
oops. $33. Okay. Like that? Thank you. Okay, so a 1,300 square foot garden. That's pretty awesome. Now, could we get, if it said rectangular, how would you get the width of the bigger garden? Yeah.
Divide the area by the length.
Yeah, just divide this 1333 by 30. That would tell us how wide it is. Now we have the dimensions of the bigger garden. Also, we could divide 30 square feet by 4.5 to get the dimensions of the small garden if it was rectangular. If I had said instead of length, if I had said radius, like this is a circle, how would you find the, using this area, how would you find the radius of the bigger one? Actually, we already knew that, so never mind. Okay. If I had given you that, you could have just calculated the area, so that would have been a different problem. That is the scaling up version from 1D to 2D. Do you want to do an example of scaling down, or are we able to do that? Huh? You think it's fine? We could do a shorter example if you want, or we just don't do one at all.
I think it's
Okay,
just,
cool.
it's just the opposite.
Yeah, good.